time series, as the name implies, a series over time. So the x is always time in these. If I could spell always. So x is always time, and these will vary over time to a couple of different ways. So what can happen is you can just have what's called secular trends, okay, which is just a general trend over a time series, like that. You can have random trends, which are exactly that, all over the shop. Okay, you can have seasonal trends, which change over the seasons. So that could be every December, if you're looking at people going on holidays or something like that. So that's a seasonal trend. And there is one other type called cyclic. So this one here is also cyclic, but cyclic is slightly different in that it doesn't necessarily have to have the same distance between your peaks. So that cycles, it goes up and down, but it doesn't necessarily have to have the same distance between your peaks. So time series, plot them the same way we have all the bivariate data. Just make sure that your x is always the time and your y value is whatever you're measuring over that time. And you also need to change that to, so if you've got 2009, 2010, 2011, 2012 as your time values, you would then translate them to 1, 2, 3, 4, just to make it easier for you when you're graphing it. Don't use the actual time code. Translate them into a number that's easier for you to use. That's pretty much it for 4A and 4B about trends and fitting trend lines. You guys go back to exercise 3 where we were talking about regression. If you're worried about trend lines and how to do it, it's all explained there because you're using the least squares or the 3 median or by eye methods for fitting trend lines anyway. So go back to them if you need a hand, but we'll keep moving on to some of the more advanced stuff to do with time series.